Hey everyone, welcome to Code World, and today we'll be going over LeetCode number 242, Valid Anagram. This is another problem off the Blind 75 list, which is a list of problems very commonly asked in coding interviews. So in this problem, we're given two strings, S and T, and we want to return true if they are anagrams and return false otherwise. An anagram is a word which can be formed from a first word by just simply scrambling or rearranging the letters. Therefore, two words are anagrams if they are composed of the same amount of characters, they have the same length, and also each of the characters present in the two strings must be identical. So every character in the string must be present in the same quantity in both of the strings. So over here we have two strings, S and T, and we see that these two are anagrams because each of the characters present in both of the strings are present in same quantity. And there are no characters in one string that are not present in the other. So all of these strings have three A's, one N, one G, one R, and one M. And because of this, we can return true. In the second example instead, we have rat and car. We see that rat has an R, and so does T, which is car. Rat also has an A, and that's also present in car, but rat has a T, which is not present in car, and car instead has a C. Therefore, these two strings are not anagrams, and we return false. So I have redrawn this example down here, and we have the first example with anagram and S nagaram. So both of these strings we said have three A's, one R, one M, one N, and one G. So what we want to do is we want to be able to go through these strings and create an algorithm which will be able to determine whether or not they are anagrams. In order to do this, we will be using hash maps, which will allow us to store the characters as our keys in an unordered fashion, along with the value, which will be the quantity of times the key is present in the string. So we're going to start off by going through our S string, and we see that the first character we encounter is an N. We have not encountered an N prior in our hash map, so we will be adding this new character, N, to our hash map. And initially, its quantity will be 1, because it is the first N we are encountering. Then we find an A in the S string, so we will add the A as well, and a quantity of 1. Following this, we find a G, and we will do the same. And then we have an A. So when we look for the A in our hash map, we see that we already have an A. So all we have to do is simply increase our quantity to 2. Then we have an R which has not been encountered in our hash map, and once again we are going to add it with a quantity of 1. We have another A, so we will have to increase our quantity of A's to 3. And finally we will add the M with a quantity of 1. Afterwards, in our algorithm, we will do the same thing for our T string anagram. So the first letter we encounter, as we see here, is an A. So we will go and add that to our hash map. And it has a quantity of 1 because it is the first string, the first character A we are encountering. Then we have an N, so we will also add that to our hash map. Following this, we have another A, so we will increment our A's to 2. Then we have a G. Then we have an R, which when we look in our hash map does not exist either because it is the first character of R we are encountering. Then we have another A, so we will increase our A's to 3. And then we have a final M, and an M has not been encountered prior. Now that we have formed our two hash maps, we see that we can go over the characters of the first hash map. We can look at all the keys and check to see if we have the same amount of characters in the T string. So we will go through the first key in our S hash map, and this key is an N. It's the N character. So what we'll do is we're going to go and look in our hash map T and check to see what its quantity for n is. We see for S, we have one quantity of n's, and for T, we also have one quantity of n's, so we're good. Then we do the same thing with the A's. We see that both A's have 3 quantities. The same thing with G, they both have one character in each string. The same with R, and the same with M. Having finished our algorithm, we have determined that both of these strings have the same amount of characters. Each character that is present in one string is present in the other, and the characters are present in the same quantity in both strings. Therefore, we know that they are, in fact, anagrams. Now, for the time complexity, we have to take into consideration that the first step in our algorithm would be to check that both strings have the same length, because we know that from the get-go, if the two strings do not have the same length, which in this case is 3, 4, 5, 6, 7, then the two strings cannot be the same, that cannot be anagrams, because either they will have different characters or different amounts of the same characters. So we will first check the length. So we can say that both strings will have length n, and being that we are traversing first string s to create its map, then string t to create its map, and then a final time we are traversing the length of the map, which is equal to the length of the string s, we know that we are traversing the strings basically 3 times. So we have a time complexity of O of 3n, which is basically linear since we can drop constants. So our time complexity will be O of n. For space, similarly, we are saving 2 hash maps, which have length which will be equal to the length of the strings. So we know also that the space complexity will be linear. So both time and space complexity will be O of n linear. Here is the second example given to us by LeetCode, this time with car and rat. We know that these strings have the same length, so we will continue on to our algorithm because they both have length 3. But this time, we will notice that they have different chars. So when going through string s, we're going to fill out the map, and we see that there is first a c, and it will have length 1, and we will put that in our map. Then we have an a with length 1, because it is the first quantity of a we are finding. And then we have again an R, which will have quantity 1. We then go over to our T map, and we see that it has one R, and it has quantity 1. There is also an A with quantity 1. And then we are encountering the first T. Now, when we do the comparisons of the two maps, we will start off with the C in the S string. And we are going to look for a C in the T map. However, when looking in the T map, we see that there are no C's. There are 0 C's in rat, while there is 1 C in car. Therefore, we could stop our algorithm directly and return false, because there is no C here. Okay, so we're back here in LeetCode, and we're ready to code up our solution. So we said that we were going to create 2 maps, one for the S string and one for the T string. And we said that as our key value pair, we will have the character as our key, and our value will be the quantity. So the first check we were going to do is to check to see if the length of the string s is equal to the length of the string t. And if not, we want to return false because we know that the strings will not be anagrams. Following this, we're going to iterate through the 2 strings and create their hash maps. So we're going to take the character at the string s at index I, and we'll take the character at index I in the string t. And we will go and insert them in the map or increment their quantity if they're already present in the map. So what we're going to use here is a getterDefault method, which will get the key value of char s, and if not present, it will then just increment by 1. So if not present, we will return 0, and if present, we will return the value of char s. And finally, what we will do after creating the maps is iterate through every character in the S map and check to see that it is in the T map and that the quantity of the characters are the same in both the maps. So in the case that one of these proves to be false, we will return false because the strings are not anagrams. Otherwise, we can return true. And this is all our code. We can run it and submit it. And we see that it works. And this is all of the code. It's only 18 lines of code, so it's pretty brief. Thank you so much for watching my video. I hope you found it helpful. If you enjoyed it, please subscribe to my channel, and I'll see you on the next one.